Our team project is parking control simulation. In this project, we will implement a simple intelligent parking lot management system. The system mainly includes two modules: parking lot status perception module and the parking space selection module. In the perception module, we will implement two levels of perception system: semi-perceptual and full perception. In the parking space selection module, we will implement greedy strategies and random selection strategies. First, build a grid road network and then construct a parking lot road network by deleting some road sections. On the basis of this road network, a parking area is constructed in the road concession, as shown in the figure. Under semi-perception conditions, vehicles may still preempt parking space resources, resulting in unnecessary cruising time. Under the condition of full perception, it can truly realize efficient parking. First, traverse all parking areas and get the occupancy rate of each area. Perceive the parking lot status, which is represented by parking area occupancy rate. Build a data frame to store parking area occupancy. Finally, the available parking area is obtained, and the parking area occupancy rate relationship table is obtained. Get a list of parking areas with occupancy less than 1. The relevant code is shown in the figure. This module first traverses all parking areas and obtains the total capacity of each area. The function addUpdate is used to update the remaining capacity of the parking area after the vehicle decides to select a certain parking area. When the vehicle enters the parking lot and chooses to park in the parking area, the capacity of the parking area is reduced by 1. Then define the leave_update function, which is used to update the remaining capacity of the parking area. When the vehicle leaves the parking space, park information is a stored vehicle parking area relationship table. After getting the list of vehicles ready to leave the parking space, then obtain the parking area where those vehicles are parked, and finally update the capacity of the area. Under the random strategies, after the vehicle enters the parking lot, the system randomly assigns a parking area with free parking space to the vehicle on the basis of semi-perception or full perception, and the vehicle immediately drives to the target parking area for parking. The flow of the strategies is shown in the following figure. We define a class allocation as a module for strategies implementation. The random allocation function is defined to implement the random strategies. In the greedy strategies, when a vehicle enters a parking lot, it will choose a parking area closest to its entrance or for parking. The flow of the strategies is as follows. In order to complete the greedy strategies more efficiently, we can define an environment class to initialize the parking area information and obtain the distance between each parking area and each entrance. After having the environment class, the initialization function of the perception module also needs to be changed. On this basis, it will be easier for us to implement the greedy strategies and add the function greedy allocation to implement the greedy strategies under the allocation class. The function needs to enter the entrance for the vehicle to enter the parking lot. Finally, run the function in the form of the main function. First, start the project file, and then reduce the maximum speed of each road section, and the driving speed in the parking lot is relatively slow. Then instantiate the environment class, instantiate the location strategies, instantiate the full perception module, and obtain the vehicle parking area relationship table. Finally, it is necessary to define the information of the vehicles entering the two intersections. First, select the parking space, then define various parameter information and requirements. Add this information to vehicle park, and finally update the full perception module. The relevant code is as follows. We implement the scene under full perception conditions. The traffic flow at each entrance is 2 vehicles per minute. The parking time is a random number in the range of 200 seconds to 300 seconds. The simulation time is 1 hour, and the parking space selection strategy is a greedy strategy, which relies on entire simulation of parking control. That's all. Thank you for your patience.